So valid, we say a sentence is valid if it's true in every model. Should I write these down, or can I just say them? I'll say them, and if you want me to write them down, I'll write them down, right? A model, we don't say a sentence is sound or a sentence is complete. We don't say that. We say a proof system is sound. We say a proof system is complete. Now, what's a proof system? Well, there are so many proof systems. The first sort of branch in the hierarchy of proof systems is the Hildebrand type proofs, which is every line of the proof needs to follow from previous things by some rule, right? There are proof systems that aren't Hildebrand, and we haven't done them, right? All right, so then given we're doing a Hildebrand type proof, what's a proof system? Kind of says what are the underlying axioms that we're going to throw in for sure, like maybe induction, and it tells you what are the rules. The rules say it's the purple table is basically a proof system, right? So, all right. So a proof system is sound. Is like a boat, it doesn't sink. If a proof system proves it, then it's true in every universe, right? Every universe in which your axioms are true. Sound means that your proofs hold water, and when they prove things, they actually are valid. Yes. All right. So a sentence, you give me an arbitrary, this is for all sentences, right? So the adversary gives me an arbitrary sentence. And then the oracle assures me that that sentence has a proof. And then it follows that that sentence is valid, meaning that it's true in every universe in which the axioms are true. Right? Wouldn't be valid. Exactly. Right? So what do? We first find a proof system that's sound. Ideally, Jeff gives you the purple table. We kind of argue. We had to argue soundness. What does it mean to argue soundness? It's every rule seems to be fair, right? The rule said if you prove A and you prove B, then you can prove A and B, right? If A is valid, B is valid, then A and B is valid, right? That's sound, right? If A or B is true in some universe and A is not true in that universe, then B must be true in that universe. That's a sound rule, right? And if you prove things using only sound rules, you prove things using only sound rules, and now you have some universe in which all your axioms are true, then you can conclude that what you proved is true in that universe. Right? Does that make sense? And that's how we actually prove really weird things about the integers. Right? We're pretty sure that our axioms are valid. We're sure our rules are sound. So if I can prove some weird statement about the integers, then I'm pretty sure it's true in every model in which the axioms are true. Well, the integers are true. All our axioms are true in the integers. Right? Everybody got that? This axiom's true in the integers. So all our axioms are true in the integers. So if we manage to prove it, then it's, yeah, I would say true in the integers, right? And it's true in the integers, right? Does that make sense? Now, the other direction would also be nice. If a sentence is true in every universe in which the axioms are true, right? Is there a proof for it? Can you prove everything? Is your proof system complete? Right? Does that make sense? No. Sound is, if you prove it, it's valid. Complete is, if it's valid, right? The proof system completes, it proves it completes the job, right? Soundness, I build a house, right? It's sound if it doesn't fall down, if it doesn't do things which are really stupid, right? So soundness says, if you build it, you put people in it, it won't fall down, right? Completeness says, hey, Bob is living on the street, needs housing. Do you provide housing for everybody? Right? And the housing system is complete if it provides a house for everybody. Yeah, yeah. Now he's making it scary. All right? So what Gödel proved, well, everybody knew their proof systems were sound. That's easy. Gödel proved that the basic proof systems are complete. Meaning, if it's true in every universe in which your axioms are true, then there's a proof for it. However, Gödel also proved that there exists a sentence, right, that is true in the integers, right? It's not true in every universe, but it's true in the integers. And he proves it has no proof, right? That's the incompleteness theorem. If you care about every universe, if it's true in every universe, there's a proof. But if it's true, if you just know it's true in the integers, it doesn't mean it's provable, right? Then we say there's sentences that are kind of inconsistent with independent. That's what they use. They say it's independent of the proof system, right? Now we're getting to more stuff than, now you're getting into hard stuff, right? Everybody good with that? No, I did cover it, right? I think it's beautiful and magical, and people who study mathematics should know the foundations of mathematics, right? It's just like the Turing machine, just like the halting problem, right? You should know that the halting problem is undecidable, right? There's no algorithm for it. You should know there's not a proof for every statement of number theory, right? I mean, that's just cool, right? I mean, there's some religious sort of uncomfortableness with that, right? Yeah, yeah. And he found some weird thing, right? But here's something that's probably, I could probably write it down in number theory, God exists, right? And is that one provable? Probably not, right? It's just there are things, there are nuances in our universe that we're just never going to understand. right? Everybody good?